Good afternoon. To give a closing address to something you were not present at, so it's quite a challenge. But anyhow, I try my best. Looking at the theme of this conference workshop, it really touches the one of the main problems of modern society. Today, there are many countries that excel in research, that have wonderful universities, wonderful basic research that is being carried in universities or research institutes. Nevertheless, in many such cases, you hardly find any kind of new technologies developing, because some of the countries lack the high-tech industry, the industry that really applies the results, the achievements from basic research. There are countries in which the industry is very developed. In fact, there are some countries in which some of the industries actually hold almost, I would say, their own universities, own research and development centers. Nevertheless, in some of those countries, I won't mention any names, in some of those countries, you would hardly find any special achievements in basic research. For example, some of such countries do not have any Nobel Prize laureates in sciences. There really is a gap between basic science and highly applied science, or if you want new technology, always have been one of the main problems of modern countries. The question of technology transfer, how to really shift things, because we are talking about different motives, sometimes even contradicting motives. In basic research, usually the motive, the drive, is the curiosity of the researcher. In applied sciences, when developing new technologies, it is usually the desire to sell a certain product that answers usually a certain need. In many cases, you can find, many scientists in basic sciences have difficulties applying this kind of applied thinking. On the other hand, some of those who excel in producing technologies lack the, I would say, the kind of the curiosity drive that just leads you to unpredicted directions. In fact, the need to employ vision, sometimes I would say even prophecy, to look at certain directions in basic sciences that have not yet been applied, but have potential to be applied. That's in many cases seem to be difficulties. I think that one of the big trends in sciences nowadays is a consequence of the big, I would say, revolution of sciences in the 20th century. In my opinion, the biggest revolution is the development of the high computing power and its derivatives, such as the development of the network. I remember that when I was a PhD student, some 30 years ago, when I heard that a certain paper on my theme of research was written, say, in Germany, usually the procedure was to go to the library to fill up a postcard. It would be sent by email to the people in abroad. I'm sorry, by airmail. Email did not exist as yet. We're so used to it. And then hoping that the other party would be kind enough to respond promptly, and then within a month, I would get the paper.
Yes or no?
I said, in the best case, if really, everything worked perfectly. Nowadays, you go to the internet, and within 5 seconds, you have the paper. More than that, you have the power of the search engines that would tell you within seconds whether there are any keywords that interest you that are present in the paper. Otherwise, you would have to read the whole paper in those days. I mean, this big change resulted in the development of the huge databases. In fact, all the journals, so essentially almost all scientific journals have become electronic or have an electronic version. But there are some other databases, and since it is really trivial to establish a new electronic journal, there are far more journals than ever. The database, which is accessible to the researchers, has grown up, without any proportion. One of the results is the inability to comprehend everything anymore. And as you can see in many sciences, the consequence of this, since no one can comprehend everything now, is the narrowing of the focus of research, of the field of interest. Now, but this is quite typical in many sciences. I have some mathematician friends here. I remember some 40, 50 years ago, there used to be a mathematician. And then there was a distinction between algebraist and topologist and analyst. But today, when you go to topology, there is a distinction between high-dimension topology and low-dimension topology, and there's a very little overlap. Now, the same happens in all sciences. If you want, for example, in medicine, where once upon a time you would talk about a surgeon, or once upon a time every doctor was essentially also a surgeon. But now then, of course, there is the orthopedic won't handle your heart. But even, if you go, if you have a problem with a certain finger, then you won't go to the general orthopedic, but to a very focused one. So since today we know much more on everything, but this came with a disadvantage. And the disadvantage is the loss of the general view. I know that in mathematics, the more focused you are, maybe you know better on a certain function, but you really lack the techniques from other fields of mathematics that could help you in investigating what you're interested in. As a result of that, what happened in really recent years, and I would say that it's a trend of about 15 to 20 years, we find new cooperations between scientists. Scientists have learned to talk to each other, not necessarily to people who are in your close field, but in fields that are close but do not overlap. But once scientists learned to do that, they also discovered the magic of conversations between different disciplines. I find it as, it's very fascinating, for example, in the development of nanotechnology in the last 10 or 15 years ago. When I was, again, a PhD student, there was no conversation essentially between the physicist, the biologist, the chemist, the electrical engineer, and the mathematician. Well, they all employ mathematics, but other than that, there was no real talk there. But then they learned to work together. And the new combinations really show you that the sky is the limit. Now, these very similar thing happens today in neurosciences, where not only exact sciences or natural sciences play a role, but also social sciences and art. The same happens in marine studies. I mean, all these multidiscipline sciences that develop today that really open the horizon, in fact, almost allow us, I would say, numerous number of combinations. But this also taught us, the scientists, to think really outside the box. And outside the box helped also for many scientists, and you can see it, for example, nanotechnology is an example, or in many life sciences studies. Thinking outside the box is also, sometimes I would say, thinking applications. Because now that when we cooperate with scientists, say the biologist with the chemist and the physicist, you also ask yourself how I can help him and how I can be helped by him. So the applicability has started to play a role in development of sciences. And you can see that in many such societies, scientific societies, nowadays, it helps finding a route from basic science to applied sciences. In other words, a new route has been paved in the technology transfer way. Now, this also, I would say, brought somehow close together the academia and the industry. And in many countries, and of course we feel it very strongly in Israel, where the industries, it started with the defense industries, but not there anymore. Namely, it is there, but in also other places, that the industries are heavily involved in the basic research that is being carried in universities and the new combinations that bring together different sciences, also bring together different areas and bring together the basic science and the applied sciences, which result in developing new technologies. I do expect this trend to really strengthen, as nowadays you can see more and more scientists looking for new combinations, and really all you have to do is really to use your imagination and to think, how we can benefit from each other. In that sense, I see this conference, and you can see the interesting variety of participants from many institutes, many disciplines, many different ways of thinking, but all are looking as to how to look at our world as one complex where we can all cooperate. So I congratulate the organizers, the local organizers, the European organizers, all the people that are involved, all the scientists and other people who are interested in that. And I wish all of us to be able to really to discover new directions, to learn to talk to each other, and then, I believe, develop very, very interesting new technologies and new directions in our world. Thank you very much. Eli? Okay. If there are any questions to the minister, you can ask on anything, with the only exception, wherever I go, the question is, when are you going to attack Iran? So that's... I
just wanted to tell you that whatever you just said, we are actually implementing here. We've got almost 80% of our academic staff engaged in applied sciences. We call it research groups. We have up to now 30 groups focused in nanotechnology, bioengineering, smart grid, oil substitution, etc. And actually what you asked for, we did it. We broke all the barriers between the faculties. So for example, in the nanotechnology group, we have people from sciences, people from electronics, the microelectronics, and two ladies from design who are using the nano powders for pigmentation of their ceramics.
Wonderful.
And it's fascinating to see these people sitting in a group, in a research group, and speaking to each other. Well, nobody understands, if the ceramics do not understand anything about the technology, but they know what to ask concerning the pigmentation. So we just broke the barriers, and we implemented what you just mentioned.
And you know, if you think of it, just 10 or 15 years ago,
yes,
it was a dream. No one could even imagine
absolutely
that science
right.
would develop in this direction. And since you mentioned, this is really the main focus, the main mission of our Ministry of Science and Science and Technology. As you know, the basic sciences, which is carried in universities and research institutes in Israel, is basically covered by our Ministry of Education through its Committee of Planning and Budgeting in the University, VATAT, so-called VATAT. The applied or highly applied research is usually being carried in the industry. In the defense industry, well, some of the ministries are involved, like our Ministry of Defense, which heavily supports the military R&D, the Ministry of Trade and Industry, which supports new innovation, and of course the private sector, which is a very important player there. And indeed, the Ministry of Science and Technology, I mean, its mission is really to form those new combinations. And what we try is indeed to group together researchers in different disciplines. But for that, you have to employ, as I say, sometimes prophecy. It's more than vision, because you really have to think really outside the box and see, what can I do together with this and this? And as you say, the results are fascinating.
Yeah.
And so...
Let me tell you one more thing. Professor Edward Yakobov.
Whom I know very well.
Yes,
by the way, do you know?
He's your friend. Yeah, I know. And let me tell you, he wears actually two hats. In one hat, he's my vice president for research. And in his second hat, he's the dean of the Faculty of Sciences. Now, as you know, and you all know, in your academies, the first 2 years are mostly dedicated to mathematics and physics.
Basics, right.
But somehow the teachers of mathematics and physics do not know what is it needed for the engineers. So actually you have 2 years dedicated to mathematics, but the students do not know why do we study mathematics. And then in the third and fourth year, they start from the beginning. What we did with Edward, with Professor Yakobov, we broke all the curriculum, and we prepared the mathematics and physics for the engineers, for the scientists, for the algorithmics, for the special assignments of the students. So now, when they study physics, for example, the pendulum, the swinging pendulum, we tell them that it's not only a swinging pendulum, this is a resonator, this is electronics, and the differential equation means something. You don't study differential equation only for differential equation. This is the solution of the resonator, of the pendulum. And we just made a totally new curriculum from the first and second year in our studies. And secondly, your chief scientist, Professor Udi Gazit, just visited us yesterday, and we really appreciated that you let him speak in front of us yesterday in our graduation ceremony. And you're lucky to have such a chief scientist.
He's another example, he's now one of the leading figures now in nanotechnology.
He's a star, yes.
But let me just, after, talking so positively about the new trend, we have to be careful about one thing. Sometimes, in such cases, people especially, I'm sure for Eduard Yakobov, whom I've known for many years, but also for myself, for the mathematician, for a mathematician, it's a radical change, because it's not only that we were used to be I won't say stuck, but we used to be concentrated in basic sciences. But for example, a mathematician really built his own world.
Yes.
I mean, the world has to be, can be even disengaged from reality. You have your own world, and then, then it's a big change and a big shift. Now, this shift and this change is so fascinating, but sometimes you can be addicted and lose the touch for basic sciences and for basic research. And we should remember that new technology always relies on the basic research. And once we are going to lose the ability to really develop pure basic research, or we are going to become invalid in producing new technologies. But anyhow, so we have to be careful.
You're absolutely right.
But again, as I said, there was a trade-off. Nevertheless, I think that very interesting.
Thank you very much.
Thank you very much.
Thank you very much.